Devastation in Texas as a deadly explosion strikes a major port.
It's hard to prepare yourself for something like that. You have to set that aside and just go to work.
In Spain, a mammoth construction becomes a major disaster.
Normally you go through life and you don't see accidents of that magnitude.
A catastrophic crane collapse in the UK sparks a desperate search for survivors.
When I entered, electrics, pipes, everything was all over the building.
And in Colorado, a vital highway that was on the road to ruin.
Those cracks just started getting bigger and bigger.
They've got to figure out how to fix the problem immediately.
With big builds, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. In big engineering, safety must always come first. Even the smallest mistake can cause a major catastrophe. Like this dredging operation on the coast of Texas.
This was an inferno of epic proportions.
A catastrophic collision on a terrifying scale.
It's a tragedy. It's shocking that they would hit something like that.
Deadly destruction that quickly became a race against time.
We knew something had happened, something big. Our goal is to save human lives.
Corpus Christi, Texas, a bustling beach destination on the Gulf of Mexico. It attracts around 11 million tourists a year. Fishing guide Captain Pierre Petrilla is proud of the town, now known as the Gulf Coast capital.
I certainly think it's the best city on the coast in Texas. It's very laid back. You have hundreds of miles of bays, the Gulf of Mexico. There's just a million things to do. It just has everything you could want from a water standpoint.
Like most Texas cities, the economy doesn't rely solely on the tourist dollar. Corpus Christi has another major moneymaker: oil.
The port of Corpus Christi is a major oil hub, shipping around 1.75 million barrels of crude a day. That's enough gas to fill the tanks of over 3 million automobiles.
In recent years, the port has regularly been the nation's top exporter of crude.
Since Corpus is a part of Texas, oil is everything. It's crucial to this area.
One strong reason for this continued success is a strategic location. Positioned on the western edge of the Gulf of Mexico, this deepwater port is a major gateway for commerce across the world.
The port's continually busy. There's constantly ships, from large tanker ships, container ships, to smaller barges coming in and out on a daily basis.
In 2019, work began on a huge redevelopment project to enable the port to accommodate some of the world's largest ships. Key to it all was creating a new dock using this 45-meter mammoth, known as a cutter-head suction dredger.
The dredge is a barge with a long attachment known as the ladder sticking out from the bow, with a ferocious-looking toothed cutter head on the end which gouges through the riverbed.
For accurate dredging, a 21-meter-long metal piling known as the digging spud keeps the stern in place, acting as a pivot, while a system of cables and anchors moves the entire dredger and cutterhead from side to side, carving out the sediment below. The debris is then pumped onto barges for disposal.
Once complete, the new channel would be wide enough for some of the world's largest supertankers to load up with crude oil for shipping all over the world.
Friday morning, August the 21st, 2020, dredging work was well underway. Nearby, Lieutenant Dan Gillis from the US Coast Guard was at the beginning of a 24-hour shift.
I was actually sitting in my office on the second floor, and one of my friends came in, and he grabbed me and just said, "Hey, something's happening at the port."
Captured on the port's security cameras shortly after 8 a.m. Disaster struck. A huge explosion rocked the port. Around 6 kilometers away, Lieutenant Gillis and his crew immediately sprang into action.
Coming on scene, we knew something had happened, something big. The amount of smoke and flames, it's hard to prepare yourself for something like that. You have to kind of set that aside and just go to work.
The blast rocked nearby buildings and was heard hundreds of meters away. It turned the dredger into a blazing inferno.
We could see there was a barge there on fire, a large column of flames shooting out of the water. So we went into rescue mode. We're a life-saving service, and that's really our goal, is to save human lives.
As tugboats battled the blaze, the helicopter crew spotted 2 people still alive, but struggling in the water.
We recognized that they were in a dire situation and needed that immediate evacuation. We saw a port police boat, but they were on the far side, and the boat couldn't access them with the flames and the heat. So we realized that it was going to be our show.
Dan and the team's quick thinking and fast action had saved lives.
We picked them up. We didn't see anyone else in the water in that area. We gave it a good search, but the state of those gentlemen, we needed to get them to the hospital.
But not everyone was so lucky. Of the 18 people working on or around the dredger at the time, 5 were injured. And sadly, 5 more lost their lives.
I think it's always a shock when something like that happens, a tragedy. It is pretty rare considering how much dangerous materials they're moving in and out of this place.
Looking back at what we did that day, the other assets that responded, everyone played a part. I'm just happy that we were able to help the gentleman that we did.
With the city reeling, an immediate investigation was launched, and the source of the blast quickly became clear. Michael Wong is a professor of chemical engineering.
What happened for this explosion was that the dredgers basically hit a pipeline that they didn't know was there. They knew it was somewhere, but they didn't realize that where they were dredging actually hit the pipeline.
In an oil terminal, underground pipelines are buried everywhere. The problem here was that the cutter head struck one of the worst possible pipes, one that was carrying propane.
Propane is a highly volatile gas. Many of us will know it from camping stoves or barbecues, but it has hundreds of other uses for heating or as a fuel for machines.
When it's stored or being transported under pressure, propane is a relatively safe liquid. But here, when the cutter head pierced the pipe, the liquid instantly vaporized, which is bad news.
The amount that was released was about 6,000 barrels of liquid propane. As soon as the pipeline broke, it released the pressure, and then the liquid evaporated to form this gas. And the gas that was generated was about a couple of, you might say, symphony halls worth of gas. All you need is one spark to ignite that highly combustible mixture.
In an attempt to swing away, the dredger increased its power. In the process, it began sucking the vapor cloud aboard. With the engines running, the highly volatile propane found an ignition source. That explained the horrific explosion and fire. But during a routine dredging operation, why was the cutter anywhere near a propane pipeline in the first place?
There's pipelines running throughout the different bays and gulf and into the port. The pipelines are very well marked.
Most of the 8-kilometer-long pipeline was visible on the shoreline, but here there was an 80-meter section underwater.
6-meter tall bamboo cane poles were placed on the channel side of the pipeline, around 15 meters apart, to act as clear markers.
But less than a month before the disaster, Hurricane Hannah struck the Texas coast just south of Corpus Christi. And while the impact on the markers is unknown, according to testimony from the investigation, crew on the dredger didn't recall seeing any poles in the area where they were working. It also turned out that the exact location of the pipe had been miscalculated in the original dredging plans.
When you have a 3-ton toothed cutter head churning through the ground, any amount of drift or deviation could be catastrophic, as it was here.
Accidents happen and people make mistakes, and obviously somebody made a major mistake that day and it cost people their life.
Following the tragedy, the investigation recommended stringent checklists and rigorous safety protocols for both dredging companies and pipeline operators.
The report called for clear dredging boundaries to be introduced, and crucially, all pipelines would need to be marked accurately and checked, both on the plans and in the water.
It was also crucial for engineers to learn from the disaster.
The most important lesson out of this tragic event is that we have to treat all chemicals and materials with respect. It's terrible that we have to wait for an event like this to remind us how dangerous chemicals are and how important safety is for all of us.
A much larger exclusion zone around any submerged pipelines was also recommended, so that nothing like this could ever happen again.
This is an all-hands-on-deck incident. Looking back on it, I'm just really proud of what my crew did that day. You know, they performed admirably. They were heroes, and everyone on the water and on land. It was definitely a big event and something that I'll remember for a long time.
In big construction, every last detail must be checked and double-checked, because sometimes one small mistake can lead to tragedy. Like this catastrophe in Spain, where a major construction project came crashing down.
This was sudden and deadly. A massive piece of structure dropped onto the valley floor below.
A devastating bridge collapse that left a town reeling.
Normally you go through life and you don't see accidents of that magnitude.
And a disaster that quickly turned to tragedy.
Empezaron la gente a dar gritos ahí, y yo y mi mujer con la mano en la cabeza diciendo, madre mía, señor mío, la pila gente arriba.
On the southern edge of Spain, along the Costa Tropical, lies the small town of Almuñécar. Although it's now a growing tourist destination, historically this community has thrived thanks to agriculture.
The Costa Tropical might be less well known for tourism than neighboring regions, but as the name suggests, the climate here gives it an advantage for growing certain crops.
Originally from England, journalist Martin Mayal knows all about this region's plentiful bounty.
It's probably one of the few places in Europe where you can actually grow subtropical fruit like the avocado, and it really made a huge difference to the prosperity of everybody who lives here.
Avocados originally came from the Americas, but thanks to its climate, this region now produces around 50,000 tons of avocados every year, which is more than half of Spain's total crop.
And getting it to market has never been easier, thanks in no small part to this. Opened in 2009, the Riviera Viaduct, which connects the area to Spain's expansive highway system.
The Spanish highway network ranks among the longest in the world, and one of its most important roads is the A7, which runs more than 1,300 kilometers along Spain's Mediterranean coast.
It's made a huge difference for getting the fruit out of the area, getting it out to the markets. The old roads were always congested in the summer, so it made a big difference, and it was very much welcome.
For local farmer Jose Maria Vacas, The bridge had been a long time coming.
Me he criado en esta zona rodeado de huerta, el aguacate, la chirimoya, cada parcela de una persona diferente. Cuando yo era pequeño, jamás pensé que iba a haber un puente de esta envergadura tan grande en el valle. Yo jamás lo hubiera pensado, nunca.
Spanning around 550 meters across the ravine, the imposing structure is not one, but two parallel crossings, each around 12 meters wide.
The bridge might look complicated, but the concept is relatively simple, using beams sitting on pillars. The eye-catching arch helps spread the load in the middle, avoiding the need for a pier to be sunk into the centre of the valley.
Building on this scale across a deep ravine in mountainous terrain is a mammoth challenge, and they had to do it twice over.
Antonio González Herrera is a professor of engineering.
El problema ahí son las dimensiones. La altura de los pilares en este caso son por encima de los 60 metros, que estaríamos hablando de como un edificio de unas 20-22 plantas. No podemos ir trasladando piezas prefabricadas y colocándolas. Entonces la alternativa que tenemos es construirlas in situ.
In this case, that meant constructing the piers first, then using a temporary mobile scaffolding system, also known as an auxiliary bridge, to build the roadway. The steel falsework sits on two huge parallel steel girders around 9 meters apart, running the length of 3 piers and always securely connected to 2. The falsework has both sliding devices and jacks, allowing it to move along the structure as the bridge is built section by section.
El puente auxiliar está apoyado siempre sobre 2 pilares, ¿vale? Entonces tiene que tener una longitud que cubra 3 pilares, de manera que cuando lo vamos desplazando, al llegar al tercer pilar, el primero ya se puede liberar como apoyo.
This is kind of like a railroad, but here, instead of a train moving, the tracks slide along, span to span, as the concrete is poured, completing the deck section by section.
Construction began in 2002, and Jose enjoyed a ringside seat from his balcony.
Me quedaba muchas horas viendo cómo trabajaban cuando yo terminaba mi trabajo y lo veía por las tardes cómo lo movían y me impresionaba.
But the long-awaited bridge that would create a vital link for both tourism and trade nearly tore this small community apart. Monday, November the 7th, 2005, near Almunica, construction on the vital crossing had reached the central span over the deepest part of the ravine. Jose Maria Vacas was at home, having lunch with his wife.
Se encontraban unos ruidos muy raros, como forzando hierro contra hierro, y no era normal ese ruido.
Jose's instinct was right. He and his wife went to investigate. What they were about to witness was the community's worst nightmare.
Salimos al balcón y ya pues, empezaron la gente a dar gritos ahí.
Shortly after 3 p.m., with workers still on top, the steel falsework suddenly collapsed.
Yo y mi mujer viendo cómo se desmoronaba la estructura de hierro y yo y mi mujer con la mano en la cabeza diciendo, madre mía, señor mío, la pila gente arriba.
The same equipment Jose had spent 3 years watching, night after night, fell around 60 meters to the ground, right before his eyes.
Pues, como pánico de ver que se estaba cayendo una cosa que jamás yo pensaba que podría pasar.
Local journalist Martin Mayal received a call to alert him that something had gone terribly wrong.
When I got here, everybody thought it was an explosion at first. Just the noise, the tremendous noise of the bridge coming down.
The community raced to help, Jose among them.
Y la primera impresión, pues, escombro por todos lados, polvo, donde hace justamente el arco.
Normally you go through life and you don't see accidents of that magnitude. So it took a long time to take it in and you just forget why you're there.
It quickly became clear that it wasn't just tons of metal that had fallen nearly 60 meters. Martin came across a distraught worker at the site of the disaster.
He was sat down with his hands in his head and he was crying. One of his friends was down below. He had been with him moments before the accident, but he had left the area to do something else and he had survived.
This narrow escape was a stroke of luck. But there had been no time to evacuate the active site before disaster struck. At the time of the collapse, there were workers both on and under the bridge. 3 were seriously injured, but sadly 6 more lost their lives. The collapse was the worst work-related accident in the region's history, and the community wanted answers.
Días después del accidente, pues toda la gente en el barrio especulando y todo el mundo preguntaba igual que cómo podía pasar eso en la época que vivimos, tener un fallo de esa magnitud.
Initial speculation focused on the bridge's distinctive concrete arches.
Some of the first photographs in the news showed one of the concrete arches on the ground, giving the impression that maybe that's what had failed.
But this arch couldn't be the cause of the collapse. It had never even left the ground. Professor of Engineering Antonio González Herrera explains.
Realmente el hormigón no cayó, lo que cayó fue toda la estructura de acero. Y eso fue suficiente para arrastrar pues, a los operarios que le afectaron.
A judicial inquiry was launched and immediately focused on the temporary steel support known as a movable scaffolding system. While the central section carries the weight of the machinery and wet concrete, the 2 lighter side sections are connected using flexible bolts instead of welded joints, allowing the structure to be more maneuverable.
En el caso del accidente del puente de Almuñécar, lo que ha identificado el informe con bastante claridad es que el origen del fallo se produjo precisamente en una de las uniones entre la parte central del puente auxiliar y uno de los laterales. Unos tornillos fallaron, se produjo el fallo inicial y eso desencadenó un fallo en cadena.
But how had a tried and true method used around the world failed so catastrophically here?
The temporary structure is under constant pressure from the huge loads on top, and also from the movement along the bridge. So the bolts need to be able to withstand massive forces.
Over time, cyclic loading or repeated stressors can cause the connections to work themselves loose, which can be disastrous.
Lo que dice el informe es que uno de los tornillos, entre la parte más rígida y la parte lateral, estaban aflojados, ¿vale? La diferencia entre un tornillo que está apretado o un tornillo que está aflojado es su capacidad resistente, ¿vale? La capacidad de mantener la unión pegada.
While we don't know for sure, this tragedy could be down to something as simple as a loose screw.
Ese tornillo debía de estar apretado, debería de estar con una determinada fuerza de apriete y lo que el informe determinó es que no era así y por ello se considera que ese fue el origen de la causa del fallo.
The weight of the bridge materials combined with the temporary structure meant this one joint failure was enough to bring the whole structure crashing to the ground.
One of the advantages of this construction system is its flexibility, particularly over tricky terrain. But here, it seems that it might have also been its greatest flaw.
In the months that followed, the rubble was cleared, and the job of rebuilding not just the bridge, but the community commenced. 4 years after the disaster, with lessons learned, the crossing was finally complete.
Siempre que mira uno al puente, siempre se acuerda uno del día de la catástrofe diciendo, ¿cómo pudo suceder una cosa así? Claro, como hace muchos años, pues lo recuerdan menos. Pero siempre, cuando nos reunimos, siempre alguna vez sale la conversación del puente.
In 2006, a plaque was erected to serve as a memorial to the workers who died that day.
This tragedy is a powerful reminder that even the mightiest structures can be brought down by the tiniest of flaws.
For engineers to build on an epic scale, the execution is as important as the planning. Just one small mistake can turn a triumph into a disaster. Like this catastrophe in the UK that struck at the heart of a city.
The next minute I heard a big, massive bang. When I seen the crane on top of the building, it was a real shock.
A sudden crane collapse on top of an apartment building.
I can see daylight at the top. There's water cascading down. They've ripped everything out there, everything.
A mammoth collision with devastating consequences.
He started shouting, "Stop, don't move, don't move. Oh my God, he's fallen." And then the phone went dead.
Liverpool, Northern England. Sitting on the north shore of the River Mersey, over the years the city and its people have made it through some tough times. John Corbett is a local tour guide.
The city rose from wartime destruction, post-war recession, and in the 1980s, regeneration arrived.
Liverpool sees a chance to reinvent itself, turning the decaying docklands into museums and art galleries, with new residential developments springing up nearby.
All over the city centre, the building can be seen by the large number of cranes and construction vehicles everywhere.
As the town grew, the construction industry boomed. But in a compact and historical city like Liverpool, building big is no easy task.
All these major projects near the downtown area share one issue: how to build big, new structures in an old, crowded city.
Narrow streets built in bygone centuries proved to be a problem for modern construction traffic.
The solution, seen in cities all over the world, were these giant tower cranes. Their job, to get heavy materials from the ground to construction happening high above.
Like any heavy lift, balance is key. And with tower cranes, that means being firmly fixed to the ground, and sometimes to the building they're working on too.
By 2009, tower cranes dominated the Liverpool skyline, temporary monuments to the construction boom. At the city centre, a new development was underway.
The project included an 8-storey hotel complex and 7-storey apartment block, all packed inside existing developments. Space was so tight, they had to close a road during construction.
A 70-metre tower crane was constructed and secured to the ground with piles, and the new buildings quickly began to rise.
Time was money, the pressure was on to get the job done quickly.
But big engineering can't be rushed without risking disaster. July the 6th, 2009. The sound of construction had become part of residents' daily life, for locals like Angela O'Brien.
There was loads of noises all the time.
But shortly after 12 p.m, Angela heard a noise that would haunt her forever.
I was just doing some dishes and that. The next minute I heard a big, massive bang.
The 70-metre tower crane had collapsed suddenly and without warning.
And that's when I seen the crane on top of the building. It was a real shock.
Tons of metal had crashed down on top of the apartment building next door. Ian Maxwell from Merseyside Fire Rescue Service rushed to the scene.
I was one of the first senior officers to be mobilised to the incident to take charge. A significant disaster that has happened in the city.
When Ian arrived, the scale of the disaster became disturbingly clear.
It was able to fall over here, lean against this building, and the rest of the crane went right over the top of the building.
The giant crane had laid itself across the apartment complex, with residents now trapped inside.
When the people came out at the balconies, they wasn't able to get out and they were worried. There's that big, heavy crane on top of the building. Is it going to fall in at any point?
With an escalating situation, emergency crews raced to help.
They were trying to get people out of the buildings. They were all scared.
But it soon became clear that this disaster was even worse than it initially appeared.
The lift wasn't working and the stairwell had caved in.
Tons of concrete counterweights had fallen from the crane, taking out a stairwell and blocking an evacuation route.
The counterweight had come right from the rooftop and punched their way right through to the basement.
Ian suddenly received a distressing phone call.
One of the managers from the building site actually handed me a phone and said, he's found the crane operator. And then he started shouting, stop, don't move, don't move. Oh my God, he's fallen. And then the phone went dead.
The operator had fallen from the collapsed crane through a hole created by the counterweight down through the building. It was now a race against time to find him.
Search and rescue teams had to scour the building for a way in while evacuating residents who were trapped in their apartments.
When I entered the window, I can see daylight at the top. There's water cascading down. Then it ripped everything out there, electrics, pipes, everything was all over the building.
Searching through the devastation, Ian and the team located the crane operator. He was still alive, just barely.
One of the paramedics was a doctor, and his simple message to us was get him out as quick as possible.
They got the man from the crane and took him out onto the ambulance, and the people also in the apartments got them out.
100 residents were evacuated from their homes. Incredibly, none were hurt. Sadly, while the operator survived the event, he suffered life-changing injuries. In the following days, Liverpool was left stunned, and the government quickly launched an investigation. The first area of concern was the crane itself. Luigi Disano is a civil engineer.
Cranes can be very dangerous because they are very high structure and they can be exposed to a number of threats.
The tower crane's slender profile and tremendous height make it extremely susceptible to the elements, high winds in particular.
Although environmental factors like high winds are known causes of crane collapse, almost twice as many are due to structural flaws or human error.
But here the crane was firmly secured to the ground.
It was initially a very safe design because it was stabilized by the pile that were used to connect the foundation of the crane with the soil.
Driven deep into the ground, steel-reinforced concrete piles are connected to the base of the crane, in theory giving it a solid foundation.
And this steel reinforcement goes through up to the base of the foundation of the crane and connects the pile itself with the foundation of crane.
But investigators found that for unknown reasons, the steel inside the foundation piles had been cut and replaced with shorter steel rods, as Luigi demonstrates.
If you start to cut or replace these rebars and you insert new element from top, then the strength became insufficient to connect the foundation with the base of the crane.
With its foundations compromised, as the crane lifted around 5 tons of building material, the shorter steel rods sheared, and the crane toppled onto the apartments next door.
So there was no continuity between the pile itself and the foundation of the crane, so which of course created instability of the crane when you start to move large weight.
Whatever the reason for the change, the result was a tower crane that wasn't held firmly enough to the ground to do its job.
Ultimately, the investigation cited failure of the tower crane's foundation as a cause. In the aftermath of the catastrophe, some engineers believe that a simple solution could have prevented this disaster.
The lesson that we have learned from this collapse is that you need 2 different practices of connecting the crane to the soil. In this case, we are using extra weight to make it more stable. And you see that during operation, there is no problem.
Heavy weights and strong pile connections is one key way to ensure that a tower crane is solid and stable enough to lift its maximum design load.
In the years since, Liverpool has bounced back, and the scars of the crane collapse are almost unnoticeable.
The buildings have been repaired, they're now high-end accommodation, and although the lessons have not been forgotten, life goes on.
When building big infrastructure, engineers must work around every obstacle nature presents. But sometimes a problem runs deeper than it first appears. Like this disaster in Colorado, where a major roadway began to fall apart.
Once the road started to go, nothing was going to stop it.
A highway on a collision course with catastrophe.
Those cracks just started getting bigger and bigger.
And a race against time to find a solution.
They've got to figure out how to fix the problem almost immediately.
Denver, Colorado, close to the foothills of the mighty Rocky Mountains. These towering peaks are part of the reason the city exists.
From its own gold rush through decades of oil and gas production, as businesses moved in, residents and tourists followed.
Keeping this bustling city moving is the state's vast road network. One of the busiest stretches is the Denver-Boulder Turnpike, also known as Highway 36. Joshua Lapley is the former chief engineer of Colorado's Department of Transportation.
So Highway 36, thousands and thousands of people are commuting every day to get to work, to go get to their kids' functions. The goods are going back and forth on semis.
Built in the 1950s, this stretch of road needed an upgrade, and in 2012, work got underway on this big-ticket project. John Murray is a local journalist.
They spend, upwards of about $500 million to widen the highway, put in, an express lane, and to make sure that, when there was traffic buildup, which is quite often, that, there's an express lane option for people to get through.
Part of the huge project would involve laying a section of highway higher than the original, flattening out the existing terrain to make for a much smoother ride, using a retaining or gravity wall to hold the raised roadway in place.
A gravity wall was chosen for this particular location because the cheapest way to do it is with a mechanically stabilized earth wall.
The wall would be made of layers of compacted soil and fabric, building up around 7 meters in a box, like a giant dirt layer cake. Concrete panels then covered the structure to form the retaining wall, protecting the soil from the fluctuating Colorado weather.
The road wasn't filled with just any old soil. It had to be strong enough to hold the roadway above. So engineers used a special mix of earth, sand, and rock that would all lock together.
This mammoth project would take time to complete.
This was a multi-year project. It took probably about 4 or 5 years.
By 2016, the upgrade was finished and the route was busier than ever. But beneath the tire treads, this brand new highway was already on the road to ruin. July the 11th, 2019, Highway 36, one of Denver's busiest roads, was crowded with the usual daily commuter traffic. But this was no ordinary day. Drivers began noticing cracks opening on the roadway of the eastbound lanes. Road crews raced to the site to investigate, but the news they delivered wasn't good. At the time, Joshua Lapley was chief engineer for the Colorado Department of Transportation.
Those cracks just started getting bigger and bigger until they opened up to eventually be feet in dimension.
For safety, the road was quickly shut down.
Closing a road is not something to be taken lightly, but when you're worried about life safety, it kind of makes the decision a lot easier.
Over the next 2 days, the roadway continued to degrade, and now it seemed to be sinking too.
We just started seeing the road get lower and lower, and those cracks opened up.
5 days later, the retaining wall supporting the road gave way, dumping tons of concrete and earth. For local journalist John Murray, this was major news.
Several of the panels were gone, like they had popped out or fallen down, and there was dirt pouring down at the bottom of that wall.
Witnesses reported that seeing the collapse was like watching a slow-motion disaster movie.
Thanks to the quick action of authorities and their decision to shut down the eastbound highway, no cars were damaged or lives lost. More than 100,000 vehicles a day in both directions were forced from 6 lanes to just 2.
We realized this was going to be just a really big disruption for the area. It's something that is just a backbone of the commuting system.
With Denver's traffic in a jam, authorities needed to uncover exactly what went wrong, fast.
They're in a pressure cooker because they've got to figure out how to fix the problem and then get started on it almost immediately.
The piles of shattered concrete and exposed earth quickly revealed a probable cause. There seemed to be a problem with the compacted soil used inside the gravity wall, causing what's known as a slope failure.
Slope failures usually happen when the soil isn't sufficiently stiff or stable to maintain its structure. There can be multiple triggers. One of the most common is excess water.
In the debris, investigators found evidence that the structure may have been lacking sufficient drainage, allowing excess water that most likely came from severe rainstorms to build up when the new road was under construction.
While it was under construction back in 2013, there was massive rains and floods in this whole area, and they didn't channel the water off of the soil that was then exposed that they were going to be building on top of.
Once material like soil is heavily waterlogged, unless it's exposed to the air or has decent drainage, it's not going to dry out.
Geotechnical engineer Srikanth S.C. Madabushi examined the findings.
Now, where water can be a problem is between the soil grains. So there are gaps in between these grains, which we call voids. Now, these voids can be filled with water, reducing its strength and stiffness, and potentially leading to collapses, as was seen with Highway 36.
Further examination indicated that the problems may have run deeper than the drainage, in a layer of clay that the retaining wall was built on. Paradoxically, this might have slowed the collapse, but also made it inevitable.
Clay and clay-like soils are made up of small, closely packed grains. This means they don't drain very well, which not only makes them sticky, but also susceptible to movement.
With the weight of the compacted yet waterlogged soil pressing down on the also wet clay below, it seems the slope failure was only a matter of time. In light of the findings, transit authorities made the decision to demolish the structure and start again. Joshua's team made a plan to rebuild with a road less susceptible to slope failure.
We took out all that fill. We drilled piles into the ground and filled them. That helped it support more weight. And then we put styrofoam blocks in, so that reduced the weight.
A material which is also much less prone to waterlogging.
Styrofoam blocks above aren't just strong and lightweight, but completely water resistant. It's the perfect solution.
Removing the weak clay and using piles instead meant the road's foundation would be solid.
Today, the new and improved retaining wall safely carries traffic between Denver and Boulder. And while the collapse of Highway 36 is in the past, lessons have definitely been learned.
It's always easy to play hindsight. No matter how hard we try, there will always be unexpected things that come up, and how we work together to solve them quickly and efficiently, that's the real lessons learned to me.